Hi students, welcome to Alpha's e-learning program mathematics class. We are discussing about periodicity of trigonometry functions. In previous session actually we have discussed about product of trigonometric functions, then how to find period, and this one is again the continuation. Now students observe here, this one is sin cube x plus cos cube x. What about here? Period. Actually we found period for all linear kind of functions. Linear means whenever they are having here first degree. Sin x here it is first degree. However x coefficient it could be 2x, 3x, minus x, whatever x coefficient, but we have taken the first degree term. So whenever you obtain here suppose sin square x, then write this sin square x as beta 1 minus cos 2x divided by 2. Okay, this one also comes under product, sin x into sin x. Therefore we can make use of here the relevant formula, and which you can convert here a first degree value. Observe here again it is of degree 1. It is not cos square, cos cube, etc. 1. And thereby what about here period of this entire function? This is nothing but a form f of x plus some constant. Therefore your concentration has to be only on this particular term, not about any other values. So then what about here period of sin square x? If you take, it is equal to period of cosine function. Period of cosine function, that means the original function divided by mod of that x coefficient, that is 2 here. Therefore you got 2 pi divided by 2, hence the answer you got how much here? 2 pi, right? Now students, therefore sin square x whenever you come across, immediately you can write in this way. But these every time need not to use formula, just by observation also you can say. First observation is 2 pi of course, because already a known value, and still lesser possible value we have to search because our concentration is always on fundamental period. Therefore for fundamental period here sin square x is there, and it is obvious 2 pi is true, whereas again pi also we want to check. That means sin of here pi plus x whole square. Replace x by how much here? Pi plus x. And thereby this value is, this value I am writing sin square x, and we are replacing x by pi plus x. Then what about this value here? It is nothing but minus sin x whole square, right? So we have started here the problem by taking f of x plus pi, right? F of x plus pi equal to this value, implies it is equal to how much actually? Sin square x. Sin square x means what is that value? F of x again. Therefore just by observation you must make sure it is a fundamental period, not necessarily be 2 pi, but it is again here how much? Pi. So some problems directly by observation also we can decide about fundamental period. Understand? Like that, let us check here some problems where instead of doing all this, direct substitution also possible. So let us have one by one have a glance. Observe here students, the first problem, that is sin cube x plus cos cube x. Now if I replace x by 2 pi, that means 2 pi is obviously period, no doubt it is, therefore one of the options given even 2 pi. And now the next option we want here, still lesser possible is possible or not. What about here lesser possible? You can't go for again the other kind of values. So that means 2 pi is 360 degrees. Therefore I'll search for 270 or I'll search for not in that way. Better lesser possible, maximum to maximum we observe here, after 2 pi immediately pi. Okay, and sometimes complementary functions like sin cos, that means 90 minus relation is there for sin cos. Then even here you have to go for pi by 2 also. Okay, so again tan chord combination, secant cosecant combination, not only pi, you have to observe even pi by 2 also possible or not for fundamental period. Understand? Suppose if I take f of x is equal to sin cube x plus cos cube x. Therefore students, by observation you can say clearly 2 pi is here the fundamental period. Understand? but we want search for other one, that is pi. So f of I am taking here pi plus x, right? Therefore this is sin of pi plus x whole cube, and again plus cos of pi plus x, how much here, whole cube, okay, and thereby this is equal to minus sin x whole cube, and this one is minus cos x whole cube, because they are falling in here third quadrant. And now this is equal to minus sin cube x and minus cos cube x. Therefore if you take minus common, you will get how much here, minus f of x. But according as period definition, f of x plus pi, we must get how much here, f of x only, not minus fx. So you can decide here pi is not possible. Once pi is not possible, no need of checking for pi by 2. Here order is very important. Once a largest value is not possible, then no need of checking for the smaller value than that one. Understand? So here once pi is not satisfying, then immediately there is no necessity for pi by 2. So finally what is our option? We must satisfy here with only 2 pi. Okay. So that means here you might have observed clearly, that is odd powers are there. Odd powers are there, therefore this kind of minus symbol, whenever it is coming with odd power, you will get again minus symbol outside. That is the reason you couldn't get the answer. So you can generalize the same problem as sine to the power of 2n minus 1x plus cos to the power of 2n minus 1x or 2n plus 1. Then you can say clearly period of that particular function is nothing but how much? 2 pi. So whenever it is having odd powers, 2n minus 1 or 2n plus 1x and plus cos to the power of 2n plus 1x, then the fundamental period is nothing but how much here? 2 pi. Okay students, now let's observe here sine power 4x, right? Sine to the power of 4x plus cos to the power of 4x. This problem, of course we have formula, but rather that I want to make use of direct observation. Okay. Now what is our function here? Sine to the power of 4x plus cos to the power of 4x. So here you are having 4, right? And next again our observation, anyhow 2 pi is satisfying undoubtedly, but next observation is our pi. Okay, so if I take pi here, as these are even powers, right? As even powers are coming here, so what's happening here? You are getting simply minus sin x, sin 180 plus x whole power 4, and therefore this value you got how much here? 4, which is nothing but how much here? F of x. Got it? Here, therefore, when f of x plus pi you got f of x, then clearly you can understand not only 2 pi, but pi is also satisfying the same thing. Again, we don't want to compromise here itself, still we want to go for lesser possible. What is still lesser possible actually here after pi? Our search is for pi by 2. Why pi by 2 here? Because these are complementary type, sin 90 minus x or sin 90 plus x, understand, equal to cos x, and thereby we want to make use of here the still lesser possible, that is pi by 2 also. Now sin power 4 plus cos power 4 we have taken f of x. Now we want to replace x by how much here? X plus pi by 2. This is only as these are complementary we are trying. Suppose here instead of cos power 4 you are having tan power 4. Understand, tan power 4, then I will satisfy only with pi, that's it. And if it is instead of sin x, sin power 4x, if you are having some cosecant to the power of 4x plus cos power 4, then also we have to compromise here itself. Then you are proceeding further for pi by 2 because of the reason sin 90 plus is cos or cos 90 plus is minus sin, and basing on that concept we are going for here pi by 2 also. Okay. Now what will happen if I write this one as pi by 2 plus x? Then this is cos sin pi by 2 plus x, and this one is cos pi by 2 plus x, right? And what is sin of 90 plus theta? Sine of 90 plus theta is nothing but cos theta. Therefore, you will get here how much? Cos x. And what is cos of 90 plus? Cos of 90 plus is nothing but how much here? Minus sin x, right? So you got here again sine to the power of 4x, and this one is here cos to the power of 4. That is the advantage of here the even power. As even power present, therefore immediately, even though minus is coming here, immediately you are getting the plus symbol. Hence you got finally what is the answer? F of x. Therefore students, observe sin power 4x plus cos power 4x, the fundamental period is how much here? Pi by 2. So these kind of options they give immediately by seeing 2 pi, very easy problem, I know it very well. Immediately you should not bubble this kind of value. Okay, you should observe carefully. Even power is there, sin and cos is there. Okay, 2 pi satisfying, pi satisfying. So we must go for again lesser possible value. Understand? And suppose let us observe here, instead of this value cos to the power of 4x, suppose if you are having tan to the power of 4x, right? And in this case, what about here the fundamental period? I can't make use of here pi by 2. The reason is tan 90 plus x is minus cot x. Minus cot x, that means you will get here how much? Cot value, and here you will get cos value, which is completely reversed to the given function. That's why we can't use in this case the pi by 2 case, whereas here you can make use of the case of pi. Understand? Pi is obviously satisfying. Observe here, therefore you can say for this kind of functions pi is here fundamental period. Now to sine to the power of 4x plus cos to the power of 4x, other method also there, because we have already proved one formula. What is that one actually? F of x is equal to sine to the power of 4x plus cos to the power of 4x. One method we have observed, that is just by observation. The other method, direct formula based one, it is what is our formula actually we have done in multiple, submultiple as well as in trigonometric ratios and identities also. This is nothing but 1 minus half sine square 2x. Hope all of you remember this, right? Now after this we write 1 minus 1 by 2 sine square, this is nothing but here theta. So 1 minus cos 2 into 2x divided by 2. Okay, what is the formula we applied? Sine square theta equal to 1 minus cos 2 theta whole divided by 2. So squares is coming whenever powers are coming, we are going to write it as first degree term. To convert as first degree term, we are making use of this formula. So here theta means you got here how much? 2 theta, and therefore 2x here 2 into 2x. Finally, what is the entire value? It is 4x. Now students, observe our concentration whenever here period problems are concerned, then your concentration has to be only on x coefficient and the particular function. What about all other values? We don't matter. Okay, we are concentrate here only. Now what about here the period of this function? It is nothing but period of this cos value, original function, divided by the x coefficient, that is here 4. Okay, then this is 2 pi divided by 4, hence what is your answer? Pi by 2. So this is actually the descriptive method, and whatever we did just by observation pi by 2, that is here objective approach. And therefore you observe sine square x formula we wrote 1 minus cos, because once you want to find period of function, it should be always here first degree, and that will be possible with this kind of formula. And after using that formula we approach here this type of value. So here what you have to observe clearly is whatever other values beside these kind of trigonometric functions, it is of the form sum a plus k times f of x. Understand? So your concentration is not on this one, not on this one, it has to be only on this particular value. That's why I did not simplify all other values, directly I have taken this particular function to find fundamental period of given value. Understand? So this one is descriptive approach, sine power 4 plus cos power 4. In the same way, if it is 6 given, right? If it is 6 given, sine power 6 plus cos to the power of 6. What is the formula we have? 1 minus 3 by 4 times sin square 2x. Okay, remember sin power 6 plus cos power 6 is 1 minus actually 3 sin square cos square. This is one of our known formula from trigonometric ratios and identities. Later in multiple submultiple we have taken this one as 1 minus 3 by 4 into 4 sin square cos square, whereas that is nothing but sin square 2x. So here same value we write. This is how much now? 3 by 4. Because it is in second degree, we want to convert as first degree. So you got again same kind of value. Hence students, what about here also period? It is nothing but 2 pi divided by how much it is? 4. So period of the function is period of cos original function divided by the x coefficient is here 4, and hence it is 2 pi divided by 4, therefore it is pi by 2. Therefore, what is our final observation when powers are coming as even powers? Understand? So whenever powers are even powers, then directly instead of doing all these, just by observation you can notice the answer is nothing but pi by 2. Once even powers are there, sin to the power of 2nx and plus cos to the power of 2nx, where n is here integer, that means natural number. So once you got this kind of values, it is n is 2, 3, 4 etc. Understand? N is 1. Again you cannot decide here fundamental period. Understand? Therefore n is more than 1, 2, 3 onwards if you got, then simply you can say here the fundamental period is nothing but pi by 2. And just one small change I want to make. If I write here plus symbol is there, suppose if I am writing 5, understand? If I am writing here 5, then in this case also can I say the fundamental period is again pi by 2 or not? Understand students? So if I write like this, then clearly the fundamental period of this function is pi by 2. Okay, suppose a small change I am making. What is the small change I am making? That is, before this cosine function I am taking here just a value 5 times cos to the power of 2nx. 5 is not particularly I am taking, you can take any kind of real number whether it is positive or negative. Understand? So some real number I am taking whether it is positive or negative. Just for example I took here 5. Now in this case can we say again the period is, that is fundamental period is pi by 2 or not? So if you take this as suppose f of x, as we have observed, pi is almost satisfying, not almost, clearly pi is satisfying, 2 pi is satisfying. Our concentration always here lesser possible value. So I am going for here pi by 2. So replace x by how much here? Pi by 2, x plus pi by 2. Then this is sin 90 plus x to the power of how much here? Whole to the power of 2n plus 5 times cos 90 plus x whole to the power of how much? It is 2n, right? So in this way we are taking. Now what about this value here? Sin 90 plus x means it is nothing but cos x whole to the power of 2n, and plus what about here? 5 times it is cos 90 plus x. So what is cos 90 plus x? Minus sin x. Minus sin whole power means you got here sin to the power of 2nx, right? Therefore students, observe here, whenever you got in this way, then clearly 5 is here, whereas here 5 is before cos. That means this is not equal to here f of x. Got it? That implies what is our observation is, as long as the coefficients are same. Understand? Coefficients are same, need not be 1. If coefficients are same, if I write 5 here, it should be 5 here, 3 here, 3 here, minus 3, minus 3. So as long as coefficients are same, then obviously the fundamental period can be here pi by 2. Once coefficients are different, then fundamental period we have to compromise only with what? Pi. That's it. Understand? So what you can generalize this kind of result? We can generalize it as here in this way, that is sin to the power of 2nx and plus cos to the power of 2nx, and if you write here some k and here also some k, then fundamental period is here pi by 2, right? And n must be here 2 onwards. And next other one, if I am writing k times sine to the power of 2nx plus some L times sine cos 2 to the power 2nx, right, like this. Now if I got in this way, then fundamental period cannot be here how much? Pi by 2, but it is only how much here? Pi. Understand, students? Now in that way, observe here, what about to this problem? 2 sine power 4 plus 3 cos to the power of 4. Here the coefficients are different. Therefore, it cannot be here pi by 2. So, what is the value here? We can write it is nothing but just pi only. And next one, sine power 6 plus cos power 6. Coefficients are same, even power. And therefore, here fundamental period is pi by 2. And next value, coefficients are different. Here 1, here minus 1, and even power. Therefore, fundamental period is nothing but here only pi, because coefficients are different. And this problem, cos square x plus sine power 4x. One of the standard problems, students, you have to remember this problem. All of you know very well this problem. Actually we did in the concept of actually trigonometric ratios and identities. Cos square x plus sine power 4x, it is one of the special functions you can say, and it is f of x. Now I want to find here period of this function, right? And you can again observe here even power, even power. Therefore clearly you might have taken this one is nothing but pi, obviously, because of even nature. And after that I want to search for pi by 2. So if I take here pi by 2, replace x by x plus pi by 2, then this will become how much here? Sine square x. And this will become how much here? Cos to the power of 4x, right? Sine 90 plus x, cos 90 plus x, whatever minus symbol compensated by here, even parts, thereby you got again plus symbol. But observe here 2 and here you got 4 cos, and here 4 and here you got 2. That means completely it is not f of x. But you know the result of the same value in trigonometric ratios and identities. You must remember these two values are always one and the same. Therefore, this is nothing but how much, students? It is f of x. We have a result cos square x plus sine to the power of 4x, which is the same as sine square x plus cos to the power of 4x, and this is equal to 1 minus sine square x cos square x, and this is actually again 1 minus 1 by 4 sine square 2x, right? So we have this kind of formula in multiple, submultiple as well as in trigonometric ratios and identities. Basing on those, you can say here, again we have observed wherever you got sine square 2x, the period you got how much? Pi by 2. Therefore, students, this is one of the special functions which you have to concentrate immediately. You can't give up, okay, period you can satisfy only with pi, but basing on this kind of result, the period of this problem is how much here? Pi by 2. Okay. So now let us observe in periodicity only the other model concept, that is in some problems they give period of the function, then they will ask about some unknown values. Okay. So let us observe problems basing on when period of a function is given. Now suppose they ask about find cosecant function whose period is pi. So what is a cosecant function? That means you can take here always a linear values. That means cosecant of, I have to take here ax plus b. Understand? So you can't take cosecant of here some x square plus 3, because this is not periodic. If I write 2 pi plus x, suppose here, what will happen? Whole square and plus 3. Understand, students? So here you can't decide what is cosecant of 2 pi plus theta etc., because it is based with whole square. Therefore, whenever any function they are asking, this must be always here like f of ax plus b. So linear function, degree is here 1. Then only we can start here. Now what about here? Suppose this one is our cosecant function. So suppose if you take this one, then what is here period? The period is by formula 2 pi divided by mod A. And this 2 pi divided by mod A, in the problem it is given as how much here? Pi. That implies here mod A equal to 2. So mod A is 2 means A equal to plus or minus 2. Now here the function we can write clearly, it is nothing but cosecant of plus or minus 2x, and constant b can be any values, just we are putting here b can be any kind of real numbers. Sometimes they give options as only cosecant of plus or minus 2x they leave. We can't say this is a wrong option because they have taken b value as 0. So in this way students, whenever they are asking about find a function when period is given, then we have to start the problem by taking in this way. And if it is a more than one answer problem, they may give this one as cosecant of 2x plus 3. Understand? And the other option cosecant of suppose minus 2x plus 1. Then these answers also right. Here period is nothing but how much? 2 pi by plus or minus 2 mod. Therefore pi, and here also pi, and here also pi, because mod symbol is there, right? And that's why you can decide here any of these options, all the values are here right answers, right? And next one, the second problem. Second problem is given as here integral value of n. The integer value of n we require when period of function is given as how much here? 4 pi. So period of this function is given. And observe here all these are first degree, sine power 1, first degree terms. And then numerator, denominator. Just in previous session we have observed about numerator, denominator whenever they are coming. Simply we can make use of LCM concept. So what about here? Numerator sin nx period. This period is nothing but 2 pi divided by n. Integer we are taking n as positive integer. And next the other value is sin x divided by n. And to this the fundamental period you can write 2 pi divided by 1 by n, and hence it is 2n pi. Finally, what we have to consider? LCM of these individual periods, that is LCM of 2 pi divided by n, comma 2n pi. So this LCM we have to consider. Then what is the formula here? Numerator terms LCM. What is numerator LCM here? It is 2n pi. Denominator terms GCD. That is what here? 1. Therefore students, what is the value here you got? 2n pi. So according as formula, we obtain the period of this function as how much? 2n pi. But they gave the value already how much here? 4 pi. That means this 2n pi is given as how much here? 4 pi. This is given in our problem, right? And that implies what is n then? It is nothing but 2. Therefore, the integral value of n satisfying period as 4 pi is nothing but how much here? 2, right? And next the third problem. It is given as cos root of p. Understand? Root of px, where p they are telling integer such that the period is nothing but how much? Pi. So what is cos root px period actually here? This is nothing but period is equal to, what is the value? 2 pi divided by root p. I am not using here mod because square root outcomes always here positive. If here 0, you will get 0, right? And therefore I am not putting here particularly mod symbol. So 2 pi divided by root p, but that value they said how much here? The period of the function given as here pi. Therefore I am taking this as pi. This is given period pi value, and it is we obtained from the formula, right? Now if I am equating 2 equal to how much you got? Root p. These two cancel. So what is p value here? It is nothing but 4. Root 4 is 2. Therefore the integer value, p is integer, they said the integer is nothing but how much here? 4, such that the period is nothing but pi. And lastly, period of cos of sin nx, right? Cos of sin nx. divided by. So whenever cos of, in previous session we have observed students like this composite functions, cos of sine, sine of cos, tan of cot, like this composite functions are given. Whenever cos or secant if you find, then you must be too cautious regarding the fundamental period. Now observe here, first we have to consider this one also, period given as 6 pi. Now here if I take period just like our previous concept or concentration only on here, for numerator the period is 2 pi divided by n, right? And for denominator it is how much? Pi divided by 1 by n. But the problem is with cos of, understand, with cos of means here you must be very very cautious, because cos of minus theta equal to cos theta. In the same way, whenever you observe here secant also, because secant of minus theta also secant theta, immediately don't write 2 pi, just check about still lesser fundamental period is possible. So what I want to observe here is, instead of here, suppose if I take 2 pi by n, is it possible here if I write pi by n as period? Because of what reason? The reason is, suppose I am taking only numerator f of x is cos of sine nx, right? And if I am taking f of it is x plus, what I want to take here? Pi divided by n. Understand? Earlier we took 2 pi by n as period. Now I am checking whether pi by n is satisfying or not, because x coefficient is here n, therefore I wrote in denominator. So cos of it is sine n into x plus pi by n. According as definition we are going. Now this is equal to cos of sine of it is nx plus n pi, right? Divided by n. So this n and n get cancelled. You got pi plus nx. What is pi plus nx actually? Sine value. So minus sine nx. It is cos of minus sine nx. But what is here? Cos of minus theta, cos theta. It is nothing but cos of sine nx. And hence what is the value you got here? F of x. So this is the danger point once you are coming across with cos composite function or secant kind of composite function. Now what is our point finally here? The numerator period is nothing but how much here? Pi divided by n. Therefore let us take here students LCM of how much here? Pi divided by n, and here the denominator period is obviously only one function, pi by 1 by n. Pi by 1 by n means n pi. Therefore, these are two fractions actually. Now the LCM is numerator LCM. Numerator LCM is n pi. Denominator GCD, that is 1. But this is given in the problem as how much this value? They said it is 6 pi. That implies this is 6 pi, and hence what is our n value here? 6. Understand? So here n value you got 6. So these kind of problems, whatever we have done now, those are basing on what actually here, when period of a function is already given, they will ask about some kind of n values or p values like that. Okay.